All right, thanks for watching and welcome to Las Payanegas, because today we'll calculate the probability of various poker events. Now, how does poker work? Let me remind you of the rules. In total, you have 52 cards, each of 13 denominations. So again, 2, 3, 4, 5, 6, 7, 8, 9, 10, king, queen, jack, ace. Okay. And of 4 different suits. So I think heart, spade, club, diamond. Okay? And what we do, we just pick 5 cards out of those 52 at random, and based on the event, we win or we lose. Now, first of all, to determine probabilities, you have to figure out how many total choices there are. But for total choices, it's not too bad because you're literally picking 5 cards out of 52. So the answer is literally 52 choose 5, because the order doesn't matter. And what does 52 choose 5 mean? It means 52 factorial over 5 factorial times 52 minus 5, so 47 factorial. And if you want to know what this is literally 2,598,960. So not quite 525,600, way bigger actually. And first, let's determine the Holy Grail, which is the royal flush. And all this is just the specific combination of 10, jack, queen, king, ace of the same suit. And if you think it's very unlikely, it is, because notice there's just one combination of denominations that does that, and there's 4 suits. So in total, there's actually just 4 favorable events. So if you want to know the probability, it's 4 over 52 choose 5. And what this is roughly, it's 0.000154%. Or, I mean, this number doesn't really tell me anything. Instead, think of it in terms of odds. The odds of winning is 649,739 to 1, which might also not tell you anything, but I want to remind you, based on the data of the National Weather Service, the odds of getting struck by lightning is 15,000 to 1, which is kind of 20 times more likely. So if you say you want to win a royal flush, you also have to say, I want to get struck by lightning kind of 20 times, roughly. So be careful what you wish for. Yeah, that's all I'm saying. Okay, so that is, again, the Holy Grail. The next one is a bit more likely, but also not that likely. It's called the straight flush. And what this is, it's any ascending order, any consecutive ascending order of the same suit. So like, for example, 2, 3, 4, 5, 6, and then same suit. And again, same suit, it means there's 4 possible choices for the suits. And for the denomination, there's not that many choices, because there's, of course, 2, 3, 4, 5, 6, but also, ace, 2, 3, 4, 5, but also 3, 4, 5, 6, 7, all the way up to 9, 10, jack, queen, and king. And by the way, what about 10, jack, king, queen, ace? Well, then you're even luckier. It would be a royal flush. So, and the question is, how many combinations are here? Well, there's 9 choices for the denominations, 4 for the suit. So in total, 36 favorable choices. 36 favorable choices, which would give you a probability of 0.00, no, less zeros, 0.00139%, or 72,192 to 1. All right, so that's, again, very unlikely. The next ones are a bit more likely, which is the 4 of a kind. And that has more to do with denominations. So what you want 4 cards of the same denomination. Think 9999. Aber 9 ist doch nicht so wahrscheinlich. And another different card, like think 7 or something. All right, and notice kind of the suits are determined because there are only 4 suits. Right? And the question is, how many choices for that? Well, there's 13 denominations, so 13. And this one, well, it cannot be one of the 13 because like 9 is already taken. So there's 12. And so what this is, well, it's 13 times 12. But for this one, we do have the choice of suit. So there's like 4 more choices for the suits. So 13 times 12 times 4, and that is 624. And so the probability would be 624 over 52 times 52 times 5. No, 52 choose 5. And the likelihood here is simply 0.024%. Again, looks better than this one, and in fact is just 4,165 to 1. Okay, not bad. All right, and now let's continue. Let's do, full house. Okay, and what is a full house? Well, it's essentially, it's a triple times a double. So 3 of a kind and then 2 of a kind. For instance, let's say 777. And then 6, 6. And here what we have to do, we again have to choose the denomination and the suits independently. So let's start with the denomination. Well, for this number, there are 13 possible choices. And for the 6 here, well, they're all the choices except the previous one. Because again, you can't pick 7. So now it's just 12 choices. And for the suits, either you can say, pick 3 suits out of 4, so 4 choose 3. Or think of it as follows, pick the not suit. So for instance, if you pick spade, then this is the same thing as saying heart, club, and diamond. That would work as well. And so in particular, there would be just 4 choices. Okay? And for this one, again, you pick 2 suits out of 4, so it's just 4 choose 2. And this is important. Whenever you're choosing something and the order doesn't matter, you have to use the choosing function because you choose to do so. And then since everything is independent, the number of favorable events is 13 times 12 times 4 choose 2, which again is just 4 factorial over 2 factorial times 2 factorial. And I think that's just 24 over 4, which is 6. So 13 times 12 times 4 times 6, and that becomes 3,744. And so the probability in that case would be 0.1141% or 693 to 1. So we're already more, than like 1,000th likely, which is good. All right, and now we'll move on to, again, something even more likely, and that's the flush. Reminds me of a joke, by the way. What do you call a fish without an eye? A fish. All right, anyway, so what is a flush? It is simply something of the same suit. but not straight flush and not royal flush. Not SF, again, straight flush, not royal flush, RF. So think again, 2, 4, 6, 10, jack, but let's say of hearts. That would be a flush. Okay, and literally what we have to do, we have to calculate the number of things of the same suit and subtract straight flush and royal flush. So what do we have to do? Well, literally you pick 5 denominations at random. So 13, choose 5. And 4 different choices of suits. And you subtract royal flush, which was 4, and you subtract straight flush, which was 36 choices. And then if you do the calculation, you get 5,108, which means the odds actually are 0.19%, and which is 509 to 1. Very good. And then something slightly different, which is the straight. All right, and the next one is straight, which I might be mistaken, but I think in French it's called la manche. Again, might be wrong. And what it is simply ascending, but not necessarily of the same suit and not a royal flush. So something like 2, 3, 4, 5, 6. And again, not straight flush and not royal flush. All right, and that's not too bad. It's easy to list all the choices. So essentially, we have A, 2, 3, 4, 5, dot, 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 up to 9, 10, jack, queen, king, and I think also 10, jack, queen, king, ace. But again, not necessarily of the same suit. And what it is, well, notice, I believe here you have 11 choices. So 11 for the denominations. And then notice, so for each suit, for each denomination, you do have any choices of suits. So you have 4 choices here, 4 here, 4 here, 4 here. So it's really 4 times 4 to the 5th power. So that is like the whole thing. But again, you have to subtract straight flush. You have to subtract royal flush. So minus 36 and minus 4. And so I wrote down 10,200, but I think it's not quite true. It's 10,200 plus 4 to the 5th, whatever that is. But in terms of probabilities, that is, again, 0.39%, or odds 254 to 1. All right, and then much more likely and stuff I'm sure you witnessed before is 3 of a kind and 2 pairs and all the other stuff. All right, and for 3 of a kind, you can think like 7, 7, 7, and I don't know, 6, 5 or something, or 5, 6. So first deal with the triple. So for the denomination, well, there are 13 choices here. And for this one, among the 12 other choices, we want to pick 2 of them. So among the not 7s, we want to pick 5 and 6. So it's actually a 12 choose 2. 12 choose 2. And then for the suit, again, if you want, just pick the not suit, so 4. And then for this one, again, you have 4 choices for the first card and 4 for the second card, so 4 times 4. And again, here it's 4 times 4 because it's okay if they're the same suit. It's not an issue at all. All right, and then at the end, what we get, 13 times 12 choose 2, times 4 times 4 times 4, which in the end gives us 54,912, which gives you a probability of 2.11% and then 46 to 1. finally probabilities with bigger than 1%. Okay, so that is 3 of a kind, and now let's do 2 pairs. So something like 8, 8, 9, 9, and then 10. And I believe this is a little bit trickier. So for the denominations, think of it as follows. You have 13 denominations, and you're literally choosing 2 out of those 13. Let's say you choose 8 and 9. So for denominations, that's 13, choose 2. And for the other one, just pick 11. Right? Because again, we chose the first one, we chose the second one, and then we're left with 13 minus 2, which is 11. And then for the suit, again, here you pick 2 suits out of 4. So 4, choose 2. You pick, again, 2 suits out of 4. And this one is just 4 choices for suits. So in the end, 13 choose 2 times 11 times 4 choose 2 times 4 choose 2 times 4. And then again, Pikachu, I choose you, but lots of choices here. And this gives you 123,552. And this is a 4.75%. Much better. Or again, 20 to 1. So kind of out of 20 random choices, you're likely to get this one. All right, and then we'll deal with way more likely things, which again, if you haven't experienced them, then you're either really lucky or unlucky, depending on how you see it. Again, think something like 4, 4. And then, 2, 5, 7. 2, 5, 8. All right, and again, in terms of denomination and in terms of suit, so for the denomination, I think you have 13 choices here. And then after the 13, you only have 12 choices, and you choose 3 of them. So 12, choose 3. And then for the suit, again, here you have 4 choices. You choose 2 suits out of 4. So 4, choose 2. And again, here you have 4 choices for this suit, 4 for this, 4 for this. So 4 times 4 times 4. All right, so in the end, what you get is 13 times 12, choose 3, times 4, choose 2, times 4 times 4 times 4. Which gives you a lot, 1 million basically, 1,098,004, not 420, 240. Okay. But it does give you 42%. Or the odds are 1.37 to 1. Which kind of weird. I might be wrong. I don't know. We'll see. All right, and then after all that, there's also the choice of no pair. Again, no soup for you. Pair, or this is something called highest card. So it's simply a random arrangement of numbers that's, again, neither ascending nor of the same suit. So 1, 2, 5, 7, 9. And of course, you could either do 1 minus all the probabilities, but it's easier to do it directly. So what we want, so among all the denominations, we want to pick 5. So 13, choose 5. But to get rid of the straight thing, you subtract 10. Because again, there are 10 choices for straight in terms of denomination. And then you want, again, pick 4 suits for each of them. 4 to the 5th. And well, because you don't want all of them to be the same suit, for which there are 4 choices in terms of suits, you subtract 4, and you end up getting 1,302,540, which is roughly a 50% chance. Or again, almost 1 to 1, 0.995 to 1. All right, so again, next time, if you're hoping that you win poker, remember me. And again, hopefully it won't make you too sad, but this is the reality. With mathematical probabilities, you get a more accurate way of winning, if you want. I mean, at least more accurate expectation of you winning. All right, I hope you like this. And if you want to see more math, please make sure to subscribe to my channel. Thank you very much.